Come on, we are live. Okay, so today's September 3rd, 2019. Okay, so a topic we're going to talk about mostly is piecewise functions. Okay, so piecewise functions. And math is always full of this vocabulary. I've had more than one kid say, why don't they just use English, Mr. Davies? Okay, so piecewise is piecing together two or more graphs, right? So you put the graphs together, because one graph, for instance, if I turn the page and look at this graph, right, you can't have one equation to describe this graph. You guys agree with that? So that's why they call it piecewise, because it takes more than one equation to describe it. And functions means simply that it's going to pass that vertical line test. It is a function, okay? So let's do this. So first of all, when I do piecewise graphs, these are my border points, okay? These are my border lines. I call these my border lines. So let me put in my XY axis. Okay, XY axis, go like that, and like that, okay? And so what I'll do is on my x-axis, because these are x values, I'm going to have a borderline between -2 and 0. Now they're invisible. They're invisible, but that's why I'm going to use a highlighter, okay? So I go -2 on the x. Here's -2 for the x. And 0, right? And then +2. And then +6, 3, 4, 5, 6, okay? And I'm just going to get, so my border lines are just going to border the pieces, right? They're not part of the graph, invisible lines. I like to start here when I do piecewise graphs. So then, using a pencil and eraser, because I'm only going to put the pieces in there, I don't want to put the whole graph in there, I'm going to graph the first one. So I have my first line, line number 1, is really f of x and y, f of x and y, f of x and y, the same thing. So graph number 1 really is a y equals a 4 minus x squared, okay? So that's a parabola, right? It's upside down because it's a negative. So I'm going to start up at 4, okay? 1, 2, 3, 4, right? And I'm going to do my 1, 1, 2, 4, 3, 9. Does that make sense? So I'm going to go 1, 1, but it's upside down. 2, 4, 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And it's symmetrical, so I also put it over here. Okay. So there we go. Okay. So far, so good. How am I doing? Everybody good? Please, will you slow me down if you need to, okay? I'm here for you. I'm not here to teach myself math, right? I'm here to help you. So, this graph exists only between -2 and 0, right? It's just right in there. That's all the graph I want to see. So I'm going to erase or not include the other part of this graph. It's not a part of it. So I didn't need to do the whole thing. I could have been smart and not had to graph the whole thing, but you know, I wanted to do it step by step. I'm going to put an open circle here. Why is there an open circle here?
Because it ends. There's nothing. Oh, because it can be equal to.
Right. Does not. It's not equal to. Do you see right here where my pin is? X has to be greater than -2, but not equal to it. So open circle here, and I'm going to graph it in and close it there, okay? How's that look, okay? Okay, now, 4 minus 2x. So I'm going to graph that one in. So go to 4. I'm going to go equation 2 is a y equals a 4 minus 2x, 2 over 1, right? So I'm going to start up at 4. I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, right? There's a y-intercept of 4. And then I go down to over 1. So my line, it's a straight line, is here. But I don't want all of that line, right? I only want a piece of it. And the piece that I want exists between 0 and 2. So I erase all the rest, okay? This is already a solid dot. Makes me happy. This one becomes a solid dot. So the second piece of this graph looks like this. How am I doing? Thumbs up. And then finally, graph number 3, fx and y, or y equals x minus 2, right? So I'll start at -2. Slope of 1 over 1. I'll go up 1 over 1, up 1 over 1, up 1 over 1. Okay. I'll graph that line in. Okay. And then I only want this graph between 2 and 6. So erase this. I already have a solid dot at 2. And I'm going to have a solid dot at 6. Okay. So here's my graph. They do not have to connect, by the way. I just like it when they do. I make these up, and I like them when they touch and connect, right? But they don't have to connect, right? But they do. They connect, connect, connect. Okay, now, domain. Well, how wide is it? It goes from -2 to 6. Does it include -2?
No.
No. So my domain is going to be -2 is less than x, which is less than or equal to 6, okay? Now, what does that say mathematically, okay? It says, read it backwards, x is greater than -2, right? Read it backwards. And x is less than or equal to 6. Now, there's another way to write these that it's called interval notation, and most kids like interval notation better. Here's how you write interval notation. This is called interval notation. And I think this is an easy way to write things because it says it's between -2 and 6. Now you notice the comma here? So the comma means what? What do you think? The comma. Comma and bracket. This is interval notation. I'm saying the exact same thing here, but in a different way to write it. If it's a comma, it does not include it. If it's a bracket, it does include it. Isn't that an easy way to write things with interval notation? Okay. Now, how about the range? How about the range of this graph? Okay, going to reach for our range, right? How about the range of this graph? What's the lowest height? Now, that's a little bit tricky, but what is lowest height? And it doesn't include 0 here, but it does include 0 here, doesn't it? Okay. Huh? Then I'd have less than, but not less than or equal to, right? How about what's the highest height? 4. So we could go 0 is less than or equal to y, which is less than or equal to 4. Or in interval notation, bracket 0, comma 4, bracket. That's interval notation. It's a much easier way to write things. You guys agree?
No. Yes. No.
Okay, either one. Both will work. I accept either one. You'll see interval notation more in calculus, so we may as well see it if you're going to take calculus, right? Okay, you guys ready to turn the page? Am I doing all right? Okay, turn the page. Okay, now, example 2. So in example 2, we want to write a piecewise function. So what I like to do to start this is I have 3 graphs, right? Let's label them. Graph 1, call it graph 2, and call it graph 3, okay? I like to start with the equations, okay? So there's equation 1. And if I look at equation 1, it looks like a straight line, right? Looks like it's down 1 over 1, down 1 over 1. So it looks like it's a y equals down 1 over 1 x. It has a y-intercept, but it got erased. It has, this graph has a y-intercept, but its y-intercept got erased, right? Its y-intercept was -4. And you have to put that in there, otherwise this line wouldn't be in the right spot. You have to put the fact that it is y equals -1x minus 4. Otherwise it wouldn't be in the right spot. But that piece got erased because it's not in that region, right? Okay. Are we okay with the negative 4? Because this graph, if you extend it, it would have an y-intercept here. Okay, good. Erase. Okay, example, or graph equation 2, y equals, and it's a parabola, right? Can you see the parabola? I see the 1, 1, 2, 4. Looks like it's a 2 subtract x squared. Right? Y-intercept of 2, it's upside down. That's why I subtract. Thumbs up. Okay, equation 3. Equation 3 is a horizontal line at a height of 1, so it's just y equals negative 1. There is no x, just
Wait,
y equals negative 1. Oh, I'm sorry, Landon. You are right and I'm wrong. Thank you. There you go. Positive 1. Thank you, Landon. So now, this is f of x, because f of x and y are the same thing, right? F of x and the same thing equals all of this. So instead of writing y, we don't have to write y, we can just write f of x, okay? How about a negative x minus 4? How about a 2 minus x squared? And how about a 1? So now let's put in the boundaries, right? So the boundaries are here, 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 and here, right? So my boundaries are in there. Graph 1, this is at negative 1, this positive 1, 1, 2, 3, 4. This is at negative 2, and this is at negative 5, right? So the boundaries are at 1, 4, negative 2, and 5, right? So my first equation is between negative 5 and negative 2. So I'm just going to write, oh darn it, let me rewrite this down here. I'm going to run out of room. Negative x minus 4, 2 minus x squared, and 1. Okay, now we put the boundaries in. So graph 1, first graph is if, we put if, negative 5 is less than or equal to x, which is less than or equal to negative 2, okay? So I already made a choice, okay? I just made a choice. I don't have to do this, but negative 2, are you watching? This spot right here, right there, I gave to graph 1. I could have left this off and given this spot to graph 2. Am I making any sense? See this equal to right here? I said let's let this graph have that point. If I'd taken this off, then I could have given that point to this graph. Okay? So now, graph 2 exists between negative 2 and 4. If negative 2 is less than x, which is less than or equal to 1. Okay, now this is where it gets not confusing because you're smart, but this point right here, right, has to count for either the first graph or the second graph. I gave it to the first graph.
So you can give it to any graph.
Yeah, absolutely. Good point. Yep. And then finally, I'm going to say the one, if 1 is less than x, which is less than 4. And again, I made a choice. That point right there, I gave to the second graph, didn't I? Right? I gave that point to the second graph. I could have given it to the first one. Okay? Just can't give the both. Okay? That's the confusing part, is the equals, right? Are you going to let this, see where my pin is? Are you going to let this point right here belong to graph 1 or graph 2? It doesn't matter, but it has to be in there, right? Can't be counted twice. This point right here, see where my pin is? You got to count that point. Is it going to go for the second graph or the third point? It doesn't matter, but you have to include it, but don't include it twice, okay? Now, I did put at 4 an open circle, right? And so I did not include that. Okay, now, what's the domain range? So domain, tell me what my domain is. Negative 5 to 4. Little notation. Put it down there, you can see it. Bracket, because it includes that value. Parentheses, that's an open value, okay? Range. Negative 2, comma. What's the highest point? 2. And is that a true value? Yeah. There you go. Questions?